In this lecture, we find out the reduction formula for sinusoidal functions. Formula number one, find the reduction formula for integration of sine to the power nx dx, where n is a positive integer greater than 2. Solution, we have to find the reduction formula for sine to the power nx dx. So let us consider In is equal to integration of sine to the power nx dx. So this In means what is the power of this function, this n. So the In represent the what is the nth power of the given function. Now we have to find out the reduction formula. So In can be break down into the lower piece. It should be In minus 2 or In minus 4 and whatever it. So now can we write down sine to the power nx in terms of sine to the power n minus 1x and sine to the power 1x? So now if we add it, n minus 1 plus 1, so minus 1 plus 1 will cancel and we are able to get the sine to the power nx dx. So now the first condition to find out the reduction formula of sine function is to break down our sine to the power nx into two parts, sine to the power n minus 1x and sine x. Now here it is very clear that we have to find out the integration of sine to the power nx, sine to the power n minus 1x into sine x. So now it is a product of two functions. So if you want to find out the integration of product of two functions, we have to use the integration by part, which is given by integration of uv with respect to x, which is equal to first function u integration of v dx minus integration of derivative of u into integration of v with respect to x and whole dx. This is called integration by parts. So clearly here the first function u is sine to the power n minus 1x and this sine x is v. So now we know that if you want to use the integration by part, we have to always check that the integration of which function is possible. So here, clearly, we are not able to find out the integration of sine to the power n minus 1x, but we are able to find out what is the integration of sine x. What is the integration of sine x? It is nothing but minus cos x. So let us use the integration by part. So first function, sine inverse of sine to the power n minus 1x. Integration of sine x is minus cos x minus this minus derivative of sine to the power n minus 1 x, which is n minus 1 into sine to the power n minus 2 x, and again the derivative of sine x is cos x into integration of v dx. So what is v over here? It is sine x. So integration of sine x is minus cos x and whole integration. So here we are applying the integration by part. Let me again explain it. So first function, integration of sine x is minus cos x minus derivative of first function. So derivative of sine to the power n minus 1x is n minus 1 into sine to the power n minus 2x. Again derivative of sine x is cos x into derivative integration of vx means integration of sine x is minus cos x dx. Let us try to simplify it. So this can be written as minus sine to the power n minus 1x into cos x. The first part is over. Now let us take n minus 1 outside and this minus will become plus. So plus n minus 1 sine to the power n minus 2x and this cos x into cos x will become cos square x dx. Now since we know that what is the value of cos square x can be written as 1 minus sine square x. So here there is no change in the first term n minus 1 sine to the power n minus 2x and cos square x can be written as 1 minus sine square x. Now let us just open the bracket. So we have to multiply sine to the power n minus 2x with 1 and sine to the power n minus 2 x with respect to sine square x. So in is equal to minus sine to the power n minus 1x into cos x n minus 1 into integration of sine to the power n minus 2x into 1 minus cos square dx. Now let us just open the bracket in the second case. So minus sine to the power n minus 1x into cos x, no change in the first part. N minus 1 we have already taken outside. And now if we open the bracket, sine to the power n minus 2x into 1 is sine to the power n minus 2x and sine to the power n minus 2 n minus 2 plus 2. So this plus 2 and minus 2 will cancel. We have sine to the power nx dx. Again, let us simplify it. We are not changing anything in the first part. Minus sine to the power n minus 1x into cos x dx. So cos x only. So this is, we are just repeating this one. N minus 1. Now here we have to open the bracket. So n minus 2x into 1 dx, the first part. And in the second part, minus this plus and minus will become minus n minus 1 into integration of sine to the power nx dx. Now, if we see this part, it is nothing but in because we have already considered before starting the question that in is what? It is nothing but sine integration of sine to the power nx dx. So let us transpose this to left hand side. Minus sine to the power n minus 1x dx into cos x plus n minus 1. This can be written as in minus 2 and this can be written as n minus 1 into in. So this will be transposed to left hand side and we have in plus n minus 1 times of in, and here what is remaining? Minus sine to the power n minus 1x into cos x n minus 1 into I2. And we have transposed this to left hand side. So now this in plus and this in minus will cancel and we have the remaining minus sine to the power n minus 1x into cos x n minus 1 into in minus 2. So, so we have only in minus 1 into in minus 2. Now this plus 1 and minus 1 will cancel. We have, and in the left right hand side, minus sine to the power n minus 1x cos x n minus 1 into in minus 2. This is already transferred to the left hand side. So plus 1 minus 1 will cancel. We have n into in, which is equal to minus sine to the power n minus 1x into cos x plus n minus 1 into in minus 2. Now let us divide the whole equation by n so that the n will come in the right hand side. So therefore in is equal to minus sine to the power n minus 1x into cos x divided by n and n minus 1 upon n into in minus 2. Therefore, the reduction formula of sine to the power nx dx, which is equal to minus sine n minus 1 n minus 1x into cos x divided by n plus n minus 1 upon n integration of sine to the power n minus 2x dx. So this is the reduction formula of sine to the power nx dx. Thank you.